Hey kiddos, today we are going to be talking about multiplying and dividing those radicals. So here's some basic steps to multiplying. First, you multiply the outside numbers together. Second, you then multiply the inside numbers together. Now, when I say inside, I mean under the radical. When I say outside, I means on the outside of the radical. And then after you do those two things, then you simplify it if possible using perfect squares method or really any method. So, number 1, I always like to underline the values that are on the outside because I'm going to multiply those first. So 4 times 3 gives me 12. Square root. Now I multiply what's on the inside. 5 times 2 is 10. All right, so here 10, we have to see if we can actually simplify that radical of 10. So I'm going to make my little factor tree. It's 5 times 2. I can't break those down any further, so that would actually be our answer. Number 2. Ooh, there's a negative. No worries, it still worked out the same. Underlining what's on the outside, I'm going to multiply those first, so negative 2 times 7, negative 14. Square root. Now, square root is going to be 8 times 3, which is 24. All right. Now, 24. Can we break that down? Can we simplify that radical? 24. All right. I like 6 times 4. And then I know 6 breaks down to 3 times 2. 4 breaks down to 2 times 2. All right. We got one pair, and then that's left over. Out, squiggle out. So this actually becomes 2 square root of 2 times 3, 6. So really, we have negative 14 times 2 square root of 6. Well, we need to multiply these coefficients basically. Negative 14 times 2 is negative 28. Square root of 6 would be the final answer for that problem. Moving on to number 3. Let's see. Oh, they made it look a little different because they now are using parentheses, which we still know that means to multiply. So we're going to multiply the number outside of the radical first. So 2 times a negative 5 gives me a negative 10. I'm going to multiply what's inside the radical or under it. I get the square root of 6. If I try and break down 6, 6 breaks down to 3 times 2. You can't break that any further, so that would actually be our end result. Next. All right, so the first term doesn't have a number in front, but the second term does, so we'll just keep that 3, because basically it's 1 times 3. And then my square root is going to be the 3 times the 6, which is 18. Now we're going to look to see if we can break down 18 by using our factor, or making a factor tree. And, well, why not use the two numbers that we just were given, right? Hello. So 3 times 6. 6 does break down to 3 times 2. Squiggle you out, squiggle you out. And I have a pair right there of 3's, and that is left over. So this actually becomes 3 square root of 2. So now when I plug it back into our problem, we had a 3 originally, don't forget about it, times this new rediscovered square root of 18, which is really 3 square root of 2. So when I multiply these values, we get 3 times 3, which is 9. Please don't say 6. And we keep the square root of 2. Hopefully you found that as a piece of cake or a piece of pie. So now let's move on to divide. Oh, don't you like my rhyme? So, steps to divide radicals. 1. Divide the outside numbers. Basically the numbers outside of the radical. Then you would divide the numbers inside the radical. 3, simplify the numerator if possible. And 4, simplify the coefficients again if possible. Remember, one of our rules is that you cannot have a radical in the denominator. So, let us begin. Alright, so basically here we got square root of 72 divided by square root of 8. So it's kind of like doing two problems, because we have to do a factor tree for 8 and then a factor tree for 72. Alright, so let's start with the easier one, and that's 8. 4 times 2, that's 2 times 2. I got a pair of 2's, and that's left over. Squiggle that out, squiggle that out. So we get to square root of 2. Now to move on to 72. So two numbers to multiply to 72. We got a lot of options. I'm going to go with 4 and 18. And I'm actually, for space sake, I'm going to actually rewrite 18 over here and 4 over there. All right, so we know 4 is going to break down to 2 times 2. 18. Let's go with 9 and 2. And then 9 would break down to 3 and 3. All right, squiggle that out, broke that down, squiggle that out, broke it down, squiggle that out, broke it down. And yeah, did that too. So I got 1 pair of 3's, 1 pair of 2's, and that left over. So I'll multiply my pairs. So 3 times 2 is 6. And then what I had left over was 2. So when I rewrite our, whatchamacallit, our fraction here, we would have 6 square root of 2 over 2 square root of 2. Well, obviously here, the square root of 2 over the square root of 2 is going to cancel out. And then 6 divided by 2 reduces to 3 over 1, or aka just 3. Moving on to the next one. So we got 6 square root of 24 divided by 3 square root of 3. First thing we're going to do is we're going to work with those outside numbers. 6 divided by 3 does reduce to 2 over 1. So I'm going to bring back the square root of 24 at the top and the square root of 3 in the denominator. Okay, so now let's work with our radicals. So again, factor tree time. Now technically 3, hopefully you know you don't really need a factor tree for that because that's as low as it's going to go. So you can't simplify that one. But 24, I got 6 times 4. 4 breaks down to 2 times 2. 6 breaks down to 3 times 2. Squiggle you out, squiggle you out, squiggle you out. Pairs, pairs, pairs. I got 1 pair of 2's and no pairs, no more. But I got a 3 and a 2 left over. So that leads to be 2 square root of 2 times 3, 6. So when I rewrite this problem, 2 times 2 square root of 6 over square root of 3. All right. 2 times 2 is 4 square root of 6 over square root of 3. Sorry, I apologize for my handwriting. Scoot that up a little bit. All right, now remember what I said, that we cannot have square root of 3 at the bottom. So it says to divide the numbers inside the radical. Can we divide 6 divided by 3 evenly? Yes, we can. So by all means, let us do that. So 4. Square root of 3 goes into the square root of 6 2 times. And we basically would have 1 left over in the bottom, so you don't really have to write it. And that would be our answer. All right, so next problem. All right, let's break down the numbers outside of the radicals. So 12 over 3 does reduce to 4 over 1. Square root of 125, square root of 5. All right, so let's see if we can break these down. I know 5 is not going to break down, so I'm not even going to write that. So 125. Well, that's 25 times 5, and 25 breaks down to 5 times 5. So squiggle you out, have a pair of 5s, and an extra 5 left over, which means I have 4. That's where I'm getting the 4 from. Can't forget about it. Times. When I rewrite this simplified radical, it's 5 square root of 5 over square root of 5. So, 4 times 5 is 20. So 20 square root of 5 over the square root of 5. Now, we know that these square roots of 5 end up basically canceling each other out, and we would be left with only 20. I'm going to let you guys do example 4 on your own. All right, so I know you guys have already taken care of business and did that on your own, and hopefully you didn't just shut off the video because you're catching on that I just added an extra example. Now, for this example, we're going to notice something's going to happen because of the radical in the denominator. So first, we would normally simplify the numbers outside of the radical, but we don't have one on the bottom, so that's a check mark. So next, we would look to see if we could actually divide 12 divided by 5 into each other. And no, not really. Not going to be a perfect number, so we're not going to do that. We can't do that. So let's see if we can break down 12. 12 breaks down to 2 times 6, and 6 breaks down to 3 times 2. I notice that I can squiggle that out and that out. I have a pair of 2's, and then we got that 3 left over. So I have 4. Bringing it down, not forgetting about it, times. When I rewrite the simplified version of square root of 12, we get 2 square root of 3. 2 square root of 3 over square root of 5. 4 times 2 is, yes, 8. 8 square root of 3 over the square root of 5. Now notice, we still can't break down these radicals, and we cannot have a radical in the denominator. So, question is, what do we do? Well, you will have to multiply the numerator and the denominator by that radical that is in the denominator. So, we multiply, we go straight across. So 8 times 1 is 8. Square root of 3 times the square root of 5 is the square root of 15. Now I'll show you a little shortcut here. Square root of 5 times the square root of 5. Anytime you have a square root being multiplied by the exact same square root, so like here, square root of 5 times the square root of 5, they're the same. What really happens is the answer just becomes, you basically get rid of the square root symbols, and the answer is just 5. And here's the proof, so I don't think I'm lying to you. 5 times 5 we know is 25, and 25 is a perfect square. So square root of 25 is just 5. So here, when I multiply square root of 5 times square root of 5, we would just get 5. Notice, no more radical in the denominator. So all we look now to do is see if we can simplify the coefficients. 8 divided by 5, you can't reduce that, so this would be the answer. This is a very good question, good example to make sure that you have and understand